Hello students, this is Harish Konda. Welcome to my channel, The Chemistry Classroom. Please like, share and subscribe. Thank you. So today I am going to explain about the substitution reactions. So what is substitution reactions? Just we explain. Okay. So substitution reactions. Generally, the saturated organic compounds will undergo in substitution reactions. What is saturated? So generally the carbon will form 4 bonds. If the 4 atoms or groups are available to the carbon, that carbon is called saturated carbon. The saturated carbon, for example, you see the methane. The compound is methane. The carbon is having 4 hydrogens. The carbon is bonded with 4 hydrogens. So this carbon is called saturated carbon. So this saturated carbon, the saturated organic compound will undergo in substitution reactions. Okay, let me explain. So here the saturated carbon, already the carbon bonded with 4 hydrogens. If it want to undergo in chemical reactions, what we have to do? We have to replace this atom. We have to replace this atom with another atom, or we have to replace the group atom or a group with another element or an atom or a group. So such type of reactions are called substitution reactions. So here to explain the substitution reactions, we take 2 examples. The one is methane and the second compound is methyl alcohol. Here in the 2 compounds, the 2 are saturated compounds. The methane is having 4 bonds, the 4 with 4 hydrogens, and in methyl alcohol also the carbon is participating in 4 bonds, so one with OH group and the remaining with 3 hydrogens. So here if you want to replace the hydrogen, so you have to remove the hydrogen from here and we have to substitute with another atom or a group. So similarly here alcohol, in methyl alcohol the OH group is eliminated and here we are substituting one element or atom and with a group. So in substitution reactions, what is the first step? So we have to eliminate the element or a group, then only we can substitute with another element or a group. So here in carbon and hydrogen, so we have to eliminate the hydrogen, so we have to break the bond. The bond is broken between the carbon and hydrogen. Similarly, the carbon and OH, so the group bond is broken between the carbon and oxygen, then only the OH group or the hydrogen group is eliminated. So generally we have 2 type of fissions. So we have, if we want to break the bond, here we have 2 types of cleavages. The one is called homolytic cleavage and the second is called heterolytic cleavage. So here generally the cleavage in 2 types. The one is homolytic cleavage and the second is heterolytic cleavage. So when you want to break the bond between the carbon and hydrogen or carbon and the group, if the electronegativity difference between the 2 atoms are equal or it is equal to the 0. So the carbon and hydrogen, for example, the carbon electronegativity is 2.5 and the hydrogen electronegativity is 2.1. If you want to break the bond between the carbon and hydrogen, how it is broken? So here we discuss. So the first type is called homolytic cleavage. In this homolytic cleavage, the bond participated the 2 elements or maximum same electronegative elements or the difference between the 2 elements are very less. Such type of elements, when they undergo in covalent bond, they are broken in homolytic. So how it is, we will explain. To explain about the homolytic cleavage, here we will take an example. For example, the 2 atoms are involved in covalent bond of the same element or the different elements which is having the less electronegativity difference in that compound or in that element or in that molecule. The covalent bond is undergoes homolytic. So how it is, you see? So here the covalent bond is concerned with two electrons, the one electron with one element and the another electron with another element. So the electronegativity difference is very light. So the two atoms all will undergo homolytic cleavage, and one electron is transferred to one atom and another electron transferred to another atom. So that X is getting one electron. Similarly that another X also getting one electron. So here we form two free radicals. So when the elements are different, they are having the electronegativity difference. So what happened here, you see, the electrons are pulled towards high electronegative elements. For example, Y is high electronegative than X. So what happened here, the electrons are moved towards the Y, and so when the bond is broken, so it is heterolytically broken, the two electrons are moved. Why? Because the two electrons are in covalent bond, the two electrons are moved towards the Y. So automatically the Y is getting negative charge and the X is getting positive charge. So it is called heterolytic cleavage. Why? Because the two electrons are moved towards one element and one atom, and the bond is cleavage heterolytically. So X is getting the positive charge and the Y is getting negative charge. So here when the bond is broken homolytically, we form the free radicals. What it is called? Free radicals. So when the bond is broken heterolytically, what they are called, one plus ion and one minus ion is formed. The one is called electrophile, which is plus ion, and the another one is called nucleophile, which is minus ion. So when the bond is broken homolytically and heterolytically, we are getting three type of particles, three type of radicals. The one is free radicals, and the another one is electrophiles, and the another one is nucleophiles. So in substitution reactions, compulsory the bond will broken first, then only that element, the element or atom is eliminated, and here we have to substitute with another atom or element or a group. So we are eliminating the group in a free radical state or in electrophile or in a nucleophile. So when the bond is broken between the carbon and the other atom, the atom will eliminate as a free radical, the atom will eliminate as an electrophile, or the atom will eliminate it as a nucleophile. So if the atom is eliminated as a free radical, so compulsory we have to substitute with another free radical only. Why? Because when the bond is broken between carbon and hydrogen homolytically, so what happened? The carbon is getting one electron and the hydrogen is getting one electron. So here the hydrogen is eliminated as a free radical. The carbon is having only one electron. That carbon free radical is formed. The carbon can bond with another free radical only. Why? Because the carbon is having only one electron. It can bond with another one electron of a different element or different atom. So one free radical, if it is eliminated, then free radical only they are substituted. Such type of reactions are called free radical substitution reactions. What they are called? Free radical substitution reactions. So why? Because the atom which is eliminated as a free radical and the atom what you have to substitute as a free radical. So one free radical is eliminated and one free radical is substituted. So such type of reactions are called free radical substitution reactions. Okay? So here we discuss about electrophilic substitution reactions. So here we take one example, the benzene. So in the benzene, the carbon and hydrogen is bonded. So if we want to eliminate the hydrogen and here we want to substitute an element or a group, so what we have to do? We have to break the bond between the carbon and hydrogen. The carbon and hydrogen is having the less electronegativity difference. The carbon electronegativity is 2.5 and the hydrogen electronegativity is 2.1. The electrons are pulled towards the carbon and the carbon is getting negative charge and the hydrogen is getting positive charge. So in benzene, generally the hydrogen is eliminated as H plus. That means the electrophile form it is eliminated. When the hydrogen is eliminated, so what you form in the benzene, the carbon is having the negative charge. So the carbon is attracted with electrophile only. Why? Because the electrophile is eliminated. Here we have to substitute with electrophile only. One electrophile here it is attached to the carbon and here it is bond formed, and what you form? The one compound you have formed. So in this reaction you observe the electrophile is eliminated and the electrophile is substituted. So where the electrophile is eliminated, the electrophile is substituted. So that such type of reactions are called electrophilic substitution reactions. So here the carbon and hydrogen is having less electronegativity difference. The electrons are pulled towards the carbon is getting negative charge and the hydrogen is getting positive charge. So the hydrogen removed as a electrophile. And the electrophile, another electrophile is attached to the carbon minus. So automatically the compound is formed. Here the electrophile is eliminated and electrophile is substituted. Such type of reactions are called electrophilic substitution reactions. The benzene compound generally will undergo in electrophilic substitution reactions. Okay. Third type of reactions are called nucleophilic substitution reactions. Here in this compound, the carbon and oxygen is bonded. Here we have the electronegativity difference between the carbon and oxygen. The carbon electronegativity is 2.5 and the oxygen electronegativity is 3.5. So the electrons are pulled towards the oxygen and here the bond is cleaved at carbon. So the carbon is getting positive charge and at the same time the oxygen is getting negative charge. Here the carbon is getting positive charge and automatically the oxygen is getting negative charge. So it is heterolytically cleavage. The bond is broken between the carbon and oxygen heterolytically. The electrons are moved towards the oxygen and the oxygen is getting negative and the carbon is getting positive. So the carbon is getting positive and OH minus ion is eliminated. One nucleophile is eliminated. Where the nucleophile is eliminated, automatically the carbon is getting positive charge. The carbon positive charged carbon can attract with only nucleophile only. Why? Because the carbon is getting positive charge, it is attached with the nucleophile only and the nucleophile is attached. So automatically what you form, for example, X nucleophile will take, the X nucleophile is added to the carbon and what you form, one compound is formed. Here the OH minus group is eliminated as a nucleophile and another nucleophile is substituted. So such type of reactions are called nucleophilic substitution reactions. One nucleophile is eliminated and one nucleophile is substituted. So automatically the reactions are called nucleophilic substitution reactions.